Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over some examples on the mean value theorem. Before we get started, let's take a look at what the mean value theorem is. So the mean value theorem has two initial conditions. First one is continuity on the closed interval. Okay, so let's say if some function if f is condition 1 continuous on the closed interval a b, and then the second condition is differentiability. Okay, so let's say f is continuous on a b, and secondly it's differentiable on the open interval. Notice endpoint differentiability is not included in the initial condition of the mean value theorem. The conclusion is that there exists at least a c in the open interval AB such that f prime of c equals f of b minus f of a divided by b minus a. Okay, so just some few things to note about this equation right here, the conclusion of the mean value theorem. That component, the right side of the equation of the mean value theorem, f of b minus f of a minus over b minus a, that can be viewed as the slope of the secant line, okay? The secant line through AB. Or it can be viewed as the average rate of change on the interval AB, okay? So that's the graphical significance of the right side. The left side also has a significance of a graphical nature. F prime of c can be viewed as the slope of the tangent line, okay, or the instantaneous rate of change at c. Okay, so notice this is the instantaneous rate of change, it's a derivative, and this is the average rate of change. All right, it is the slope of a secant line. Okay, let me give you a visual illustrating the connection between these two. Let's take a look at this graph right here. Now we can see that this graph satisfies the initial condition of the mean value theorem. How do we know? The graph is differentiable on the interval and the graph is continuous. Okay, there are no discontinuities or points where we have vertical or no tangent lines. Okay, so this graph is continuous and differentiable, so it meets the initial conditions of the mean value theorem. So there has to be a c that satisfies the conclusion. All right, so let's go ahead and put some labeling on this graph. So this is the interval AB that we are going to be looking at. And then the output, when you plug in A into the function, is f of A. Output for B is f of B. Now, that line that we have drawn there, the blue line, what is the name of this line? Is it the secant line or the tangent line? If you notice, this line goes through 2 points on the graph. That makes it a secant line. So this will be the left side, the right side of the equation of the mean value theorem, okay? All right. Now that's a C I'm going to select. Well, what's so special about that C? If we draw the tangent line to this curve at the point C, what you notice is that this tangent line is parallel to the secant line. What does that mean? That means that the slope of the secant line is equal to the slope of the tangent line. And that's exactly what the mean value theorem is saying. Okay? So, mean value theorem, the right side is f of b minus f of a divided by b minus a. That's the same thing as y2 minus y1 over x2 minus x1 that you learned in algebra. Okay? So that's the blue line, the slope of the secant line. The red line, this one, to find the slope of a line at a point, you have to use calculus. You can't use algebra for that. Okay, so this C is basically telling us the conclusion that at this point C, the slope of the tangent line at C, which is the same thing as the derivative at C, is equal to the slope of the secant line. Okay, so this is the conclusion of the mean value theorem. All right, now let's go over some examples to see if you can determine the C that satisfies the conclusion of the mean value theorem graphically. Okay, now let's take a look at this situation here. The question is, does the function satisfy the initial conditions of the mean value theorem? If so, sketch the mean value and find the C or C's that satisfy the conclusion. All right, so let's take a look at this graph right here. Does it satisfy the initial conditions of the mean value theorem? Continuity is the first condition. Is this graph continuous on the closed interval AB? The answer is no. There is a removable or point discontinuity at this x value here. So since this graph is not continuous on the closed interval, it does not satisfy the initial conditions of the mean value theorem, which means that there is no C that satisfies the conclusion. Okay? So let's write down some notes. The function does not satisfy the initial conditions spell that again, initial conditions of the mean value theorem. Okay, the initial conditions of the mean value theorem. And why is that? Since f is discontinuous. This is continuous on AB. Okay, so if you have a discontinuity or a point where the derivative does not exist, then there is a violation of the initial conditions of the mean value theorem. All right, let's take a look at this example. Does the function satisfy the initial conditions of the mean value theorem? If so, sketch the mean value and find the C's or C's that satisfy the conclusion of the mean value theorem. Okay, so there are two tests that we're going to do since we have two initial conditions. Condition number 1 is continuity on the closed interval. So let's say this is a and this is b. Is the function continuous on AB? The answer is yes. There are no discontinuities of any sort. So this is good. Now, is the function differentiable? The answer is yes. How do we know that it's differentiable? You want to ask yourself, are there any discontinuities? No. Are there any corners? No. Any cusps? No. Any vertical tangents? No. So, since we do not have any corners, vertical tangents, cusps, or discontinuities, then this function is differentiable. So since the initial conditions are satisfied, that means that there has to be a C or C's that satisfy the conclusion. Okay? So first thing we want to do is draw the secant line. So there goes my secant line through the two endpoints. Now my secant line is horizontal. Okay? This is known as a special case of the mean value theorem. This is the Rolle's theorem, where the slope of the secant line is 0. Now, if the slope of the secant line is 0, that means that there is a point, at least one point in the interval, where the slope of that tangent line will also be 0. So can you see the first C? Well, all we just have to do is take a horizontal line and see where the tangent line is horizontal. Okay, so see this horizontal line? Just make it tangent to the curve. At this point, we have a C that satisfies the conclusion of the mean value theorem. Is that the only C? Is there another C that satisfies the conclusion? Is there another tangent line that is horizontal? That's the question. Well, let's move it up. Boom, right there. Okay, so what do we have? We have 2 points, 2 C's that satisfy the conclusion of the MVT. So what are the 2 C's? We can just simply trace it down right here. This is the first, or let's call that the second C, and then we can call this the first C. Okay, so this is C1 and this is C2. So these are the 2 C's that satisfy the conclusion of the MVT. Okay, thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or suggestions for tutorials to make for you, feel free to include it in the comments section below the video. Also, feel free to visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day.